In the previous lecture, we began our study of Aristotle and his natural philosophical system. We looked at a number of issues regarding Aristotle's thought. We examined his doctrine of hylomorphism, his notions of change, his enumeration of the four causes as the way to gain knowledge of a thing, his notion of nature, and the division that he posited between natural and artificial objects. I also suggested that one of the best ways to approach and to understand Aristotle's system is to pay particular attention to his biological preoccupations. I suggested that biological systems, living systems, are used in an explanatory manner and in a fundamental sense by Aristotle in his system. In this lecture, we're going to pay attention now to Aristotle's cosmology, his physics, and his dynamics. Aristotle took much of his cosmic order from contemporaneous astronomy. Namely, the Earth is at the center, immobile, as common sense affirms, and the celestial bodies move around it. Now, if you don't believe me that the Earth is standing still, just think about it. You don't feel it. If the Earth were rotating fast enough in order to complete one cycle in 24 hours, then why wouldn't the clouds and birds in mid-flight be left suddenly behind? For example, also, if I were to jump into the air, when my feet leave the ground, the Earth would turn under me at about 700 miles an hour, and that wall would come crashing into me at 700 miles an hour. Well, the Earth is not moving, clearly. The celestial bodies are carried around by the motions of spheres arranged concentrically around the Earth. So think of the universe like an onion. And it's got these spheres getting smaller and smaller and smaller, and finally the Earth at the center. The highest sphere contains the fixed stars, and it rotates around us once in 24 hours. The other spheres deal with the motions of the planets, the sun, and the moon. We're going to talk about that in greater detail in a lecture that's devoted just to Greek astronomy. For now, it's just enough to realize this concentric spheres model. Aristotle's universe is divided into two distinct realms, and it's divided by the sphere of the moon. The moon is on the sphere that's closest to the Earth, and that sphere of the moon is the dividing line between two realms. Below the moon is the sublunary realm. This is the realm of change. Here, everything is made up of the four elements. Things come into being, and things pass away. This is the site of Aristotle's dynamic nature, dynamic world where change is everywhere happening around us. Forms come and go. The four elements that constitute the sublunary realm all have what Aristotle calls natural places, places they're supposed to be. Two of the elements, earth and water, are absolutely heavy, and so they fall to the center of the cosmos, that is, to the Earth. Fire and air are absolutely light, and so they rise to the sphere of the moon, to their natural place. Now, the elements have natural motions towards their natural places. This natural motion is rectilinear motion. They move toward the places they are supposed to be in straight lines. Therefore, if I were to take a stone, for example, and drop it, it would follow a straight line path towards the center of the Earth by virtue of its nature. Similarly, if I had a burning candle and I tilted the candle in various ways at the risk of burning my hand, the flame would always point upwards, upwards towards the sphere of the moon, to the realm of fire. Now, given this idea of natural motions, the Earth must obviously be spherical, because all the Earth, all the element Earth in the universe and the water must find its natural place, its lowest place, which would be equidistant from the center. Now, important message. If you take nothing else from this course, take this, that the Greeks knew that the world was spherical, that the Romans knew that the world was spherical, the Arabs knew that the world was spherical, the Middle Ages knew that the world was spherical. They all knew that the world was spherical. I take a poll in every history of science class I teach, and I ask my students, how many of you were taught in the 4th, 5th, 6th, 7th grade that Columbus proved that the earth was round and everybody was afraid he was going to fall off the edge? And the average comes out to be 75 to 80% of the students raise their hands. This is totally bogus. Aristotle wasn't even trying to convince his contemporaries because his contemporaries already knew that the world was spherical. All he does is he's exhaustive, the way Aristotle is, and he enumerates the ways we know that the world is spherical. One, by theory that I just mentioned, Earth tends towards the center. It's going to make a mass that is equidistant from the center, therefore a sphere where the surface at all points is equidistant from the center. But there are other things. Observations of lunar eclipses. The Greeks knew perfectly well that a lunar eclipse was caused when the Earth comes between the sun and the moon. And so we see the shadow of the Earth move across the moon. Remember that even though the Babylonians were very good at predicting when eclipses would occur, they never seemed to care to ask why they occurred. But the Greeks did. Well, they knew it was the Earth's shadow. And you can see when you watch an eclipse, Aristotle watched eclipses, you can see that it's the shadow cast by a spherical body. Aristotle also notices that if you travel south, you see stars that you don't see further north because they appear above the horizon. If the Earth were flat, all of us, no matter where we were on the Earth, would see exactly the same stars. Moreover, he knew that if you go east to west, the time of sunrise changes. The sun rises at different times for different people on an east-west line. If the Earth were flat, the sun, as soon as it came over the horizon, would illuminate the entire surface of that flat Earth, which doesn't happen. And also, the Greeks knew the observational example that when a ship sails out from the harbor, the first thing that disappears is the hull, and you see the masts for a while. So, please, remember, there was no question about this. The myth that the people of Antiquity in the Middle Ages thought the world was flat was invented in the 19th century, and it's been passed down from school teacher to school child ever since. It's time to break the cycle. Now, above the sphere of the moon is another realm. This is the superlunary realm. Here, there is no change. Aristotle was aware that the Babylonians and the Egyptians had observed the heavens for centuries before his time. Eclipses always came when they were supposed to. The seasons change when they're supposed to. The phases of the moon go round in regular cycles, always at the same time. Nothing new ever appears, nothing changes in the heavens for centuries, according to the Babylonian records. So, clearly, there is no change in the heavens. The heavens, however, are not made of the four elements. They couldn't be, because they would be out of their natural places. If the moon were made of earth, well, then it would fall to the ground, to our ground, to the earth, to the center of the cosmos, where heavy elements go. The heavenly bodies are composed of a fifth element, a quintessence, fifth essence, or ether. Nothing comes to be or passes away because the fifth element is eternal and homogeneous. While the four elements have natural rectilinear motion towards their natural places, the fifth element cannot have that same kind of motion because rectilinear motion implies going from point A to point B, so that at point B, it's at a different place than at point A. The heavenly spheres have to have a kind of motion that is continuous but doesn't change their position because they have to stay in the same places. So what's the solution? Why? Circular motion. Because in a circle, the beginning point and the end point are the same all the time. So the natural motion of the fifth element is uniform circular motion, so the heavens never run down. Now, Aristotle's dynamics flow from this cosmology, and his notions of motion, I think, are related to biological living system exemplars. Now, first of all, let me say that Aristotle has a much broader definition of what motion is than we do. This is partly because of the Greek words he's using, that the Greek word kinesis can mean both change and motion. So motion, change, they're similar concepts for Aristotle. He's got three kinds of motion. The first one is local motion, and that's the kind of motion that we're familiar with, moving from point A to point B. Change of place. The second is motion of quality. Now, what on earth does motion of quality mean? Motion of quality means that a form is changing. So, for example, if we watch an apple ripen, it starts out being green, and over time, through the summer, it becomes red. The green apple had a form of greenness, the red apple one of redness. The green apple was red in potential, green in actuality. So here again is a motion of quality from one end of a continuum, or one part of a continuum of qualitative colors from green to red. There's also motion of quantity, and that's change of magnitude. So we have a child that grows into an adult, changes in size. Obviously, there are also changes of quality that go on in that growth as well, but we're concentrating right now on the change of magnitude. Now, defining these things as motion is a little bit strange to us in our modern world because we're used to modern physics. In physics, or classical physics, we tend to look only at quantifiable motions. The motion of a projectile, quantifiable. The dropping of a body, it's quantifiable. Acceleration and velocity. We all have mathematical formulas to express these. Our science, at a very deep level, is interested in quantities. Aristotle's natural philosophy, on the other hand, is much more interested in qualities of things. And again, we might possibly make the connection to his interest in biological issues. It's a lot easier to deal with qualities in living systems than quantities. It's hard to quantify a frog, right? It's easy to quantify a falling body. Aristotle's looking at qualities mostly. Again, it's a choice of how to put together a world system, a scientific world system. Neither is really self-evident, neither is wrong. They respond to different needs. They respond to different backgrounds and different questions. Well, let's now look at two kinds of motion. Motion, first I divided into local, quality, and quantity. Now let me divide motion a different way into natural, which is according to nature, and violent. Natural local motion is, for example, when an object falls to the ground. If I let this orange drop, it's going to fall to the ground. Well, it should. It's made up of earth, for one thing. This one's a little dried out, so it doesn't quite have as much water in it as it should. But again, a heavy element. It will have a natural motion in rectilinear form downward to the earth. Why does it do that? Why does the orange fall? Notice I'm not doing Newton. With an apple, I'm using an orange for Aristotle. Why does it fall? Well, it's a natural object. As a natural object, it has a natural internal principle of change or motion. And that internal principle of change or motion drives it onward towards its final cause, because the final cause of its motion is to get to where it belongs, to its natural place. So when I hold it here, it is falling in potential. It is in potential on the ground. Notice, by the way, that we still use that word potential in physics. We talk about the potential energy of a body that's suspended above the earth. It's an echo of Aristotelian ideas. When I drop it, its motion begins because it's seeking out its natural place. The internal principle of motion is driving it on towards its final cause, the final cause of that motion. Natural motion. Now notice that the mover is internal to the natural object. And contrast this to what Sir Isaac Newton tells us, that two objects, the orange and the earth, act on each other. They both move towards each other. The orange, of course, doing the majority of the moving. but it's the force of gravity acting on the orange from the outside that pulls it downward. For Aristotle, it's a different view. It's the orange itself that has the mover. It's actualizing its potential. It's moving towards its natural place. Now, this means that Aristotle makes a very interesting comparison, or that a comparison is possible in Aristotle. We take an acorn. What's the final cause of the acorn? To produce an oak tree. We put the acorn in the ground, it grows in due course, and becomes an oak tree. Why? It's a natural object, has an internal principle of motion or change, driving it on towards its final cause, or towards its end, I should say. That means that the growth of an acorn into a tree is analogous to the falling of a heavy body to the earth. Now, that's a very interesting comparison, and not one that we're likely to make as moderns. But both of those motions, the motion of quality in the acorn moving to oak tree, which is also a motion of quantity, and also because the oak tree is higher than the acorn, it's a motion of local place as well. Those motions of the acorn are analogous to the motion of falling bodies. Okay? Sometimes it's a little bit of a hard concept if we're not willing to suspend our belief for a little while in our modern system of physical dynamics. The falling object, moreover, does not stop until it either reaches its end, its natural place, or is stopped artificially. So if I take the orange and I drop it, it should fall all the way to the earth, unless, of course, I catch it. An external agent, my hand, has interfered in its reaching its end, and it stops there. Notice that this can happen in natural objects as well. If we go into a chicken house, and at the risk of getting our hand pecked, we reach under a chicken and grab an egg. We take that egg. What's the final cause of the egg? A chicken. It has an internal principle of motion, which will actualize its potential into being a chicken. We take that egg and we come in and we put it on the kitchen table. We have now removed it from the warmth incubating heat of the mother hen. It will not hatch. We have interfered with its motion. Well, what we can do in that case, we can first of all realize that that interference is the same interference as that. I'm interfering with the orange. But we can also call techne, art, to the assistance of that poor defenseless egg. Because we can take the egg and put it in an artificial incubator, and it will hatch into a chicken, which is what Aristotle means when he says art, techne, craft, can help nature reach her appropriate ends if something stands in the way. If nature is unable to complete the end properly, art, craft, technology, techne, can come to the assistance. Right. Well, those are all examples of natural motion. But when I mentioned natural motion, I said there's also violent motion. What is violent motion? Motion contrary to nature. Nature is an important force. It's an important guiding principle for Aristotle. You don't do things contrary to nature. If I take this orange and I move it upwards, I throw it up like that. Well then, for the first half of its travel, it's moving, as Aristotle would say, violently. In other words, contrary to its natural motion, the motion it would have if I just let it drop to find its natural place. You'll notice, however, that because that motion is contrary to nature, it perishes, and natural motion takes over within a few seconds. This violent motion can only be impressed upon the orange from an external source, namely my hand. Even when I do this, when I just raise the orange, I am forcing it in violent motion because I'm forcing it contrary to the way it wants to go. So when I throw it into the air, that violent motion takes it up to the peak of its activity, at the peak of its ascent, and then that artificial motion, that violent motion perishes, and the orange starts to fall. let's use Aristotle the way he meant to be used. He wanted to have a methodological system that taught you to ask questions and find causes and find purposes in all phenomena and objects. There's a problem. When the orange leaves my hand, it should stop moving immediately and fall. It should not keep rising. Why? Well, because it's no longer in contact with the external mover. How can the orange keep moving contrary to nature if an external force is not acting on it? Well, it's left my hand. My hand is no longer touching it. It should, as soon as the moment it leaves my hand, it should fall. But it doesn't. How do we explain that? Well, Aristotle tried to explain it, and it must be said, not very successfully. He says that it is the medium through which an object moves that keeps the violent motion going. In other words, it's the air. As the orange moves, the air in front of the orange is pushed out of the way, and it rushes behind to the back of the orange and gives it a little push further. Now, how satisfied Aristotle was with this explanation, we don't really know. It was an answer, but it wasn't very long before his commentators and his followers expressed their dismay at this answer. One of the simple disproofs of it is if you put the orange on your hand like this and wave the air, I can't really get that orange to move. The air doesn't seem to be a really good medium of an external forcing agent to get an orange moving. This is an important point. It is sometimes said that Aristotle exerted a negative impact on the history of science because of his authority, that everybody just listened to what Aristotle said, and his authority was so great that no one questioned it. This is not actually true. It is true that Aristotle's system was used for 1,500 years, more or less, particularly in the Islamic world, and particularly in the Christian world in the High Middle Ages. But people were always feeling free to disagree with Aristotle. And that will come out very clearly immediately in the next lecture when we talk about Aristotle's immediate successors. But in the lectures on the Middle Ages, we'll see that medieval thinkers tended to pick a quotation out of Aristotle to start discussing Aristotle, but they made most of their living, in a sense, disagreeing with the philosopher. We'll see that in due course. Now, I think one of the best ways for really understanding Aristotle is to spend some time thinking like an Aristotelian. Aristotle's natural philosophical system was meant to be used. I want to emphasize that point. It has facts about nature. His works on animals contain lengthy descriptions of animals, exhaustive coverage of the internal parts, the movements of animals. His works on meteorology and geology are the same way. But the point about Aristotle, and the point why he's so important, is that he gave a system, a methodology, a logic for carrying out further investigations of the natural world. So, to reiterate, if you want to really understand Aristotle, don't be content with just reading him. You have to think like him for a little while. And he does make it easy for you to do, because he is exhaustive. He tells you, go look for the four causes. Think about actuality and potentiality. Think about internal principles of motion. Think about external moving agents. So let's try that for just a little while. Let's take an object. Let's take, for example, a fine example of Greek pottery. Clearly, I'm sure this is a crater used for mixing water and wine before a drinking party. Let's first look at this object and isolate its four causes. Okay. What are the four causes? Well, there's one, the material cause, the efficient cause, the formal cause, the final cause. Okay. Efficient cause. Well, the efficient cause is the potter and the vase painter who made this object. That is the efficient cause. The material cause is clay, although you may notice, in fact, that the clay, this is a little different from the kind of clay when you dig it out of the ground. Clay isn't this hard. It would, you know, clay is more friable than this. So this clay has changed in quality a little bit. The clay has undergone a motion of quality. How has it undergone a motion of quality? Well, it was put in the potter's kiln and fired. And so now it has gone from a quality of brittle friableness to hardness. It's like it's a ceramic now. Fire, remember, is an external agent. It's external to the clay, so that motion of quality must have been a violent motion of quality. What is the final cause of clay? I'm not sure about what the final cause of clay is. It does something in the ground, presumably. I'll let you think about what that might be. Let's get back to the causes of the vase as a vase, not as clay. Formal. Formal is, well, the shape, the smoothness, the hardness, the red-brownness, the blackness of the lines. What about the final cause? The final cause is, well, to celebrate the person who is painted on the vase, his physical beauty, presumably. It's also to be used to mix water and wine. So now that we have the causes, we have some context for this item. We understood who made it, what it's used for, what it's made of, what it's made into. So we've positioned this object in a context, and that's part of what Aristotelian natural philosophy is about. Well, let's see. What about other motions it can take on? Well, what if I were to drop it? Well, you would say, well, wait a minute. This is an artificial object. Remember, artificial objects do not have internal principles of motion. Therefore, if I were to take this pot and drop it, nothing should happen. Because as a non-natural object, it has no internal principle of motion. Well, let's just put Aristotle to the test. Oh. Well, Was Aristotle wrong? Well, I think not. I think we made a mistake. You may remember in the previous lecture, what I said was that Aristotle was very good at making distinctions, zeroing in on the essential parts of questions. The pot did not fall as a pot. It fell as a piece of clay that accidentally had the shape of a pot. So in fact, acting as a natural substance, as clay, it fell. Acting as a pot, it did nothing. Well, now, let me just try and sum up some things about Aristotelian ideas. Some people have said unfair things about Aristotle, that his system was just semantics and full of obscurities. And although Aristotle sometimes is rather obscure, we have to remember that to a considerable extent, this is the rhetoric of the 17th century come down to us. It's the rhetoric of people who wanted to dethrone Aristotle from his position of preeminence. And when we get to the 17th century, we're going to find that some of those very same people that wanted to dethrone Aristotle were still using his methods. The thing to remember about Aristotle's approach is that his questions were different from ours. He used examples from the living world as examples and as exemplars for natural actions. We choose to use non-life. We have a predominantly quantitative science. Aristotle's is predominantly qualitative. These are our choices. Now, we're undoubtedly correct to say that Aristotle got some things wrong. And we'll see this in the next lecture. But we have to understand that Aristotle was, in fact, asking different questions for different purposes. He was keen to understand the purposes of things. What are things for? And this is a question that modern science has largely stopped asking. For what purpose is there a universe, or a moon, or 147 different kinds of centipede? These kind of questions modern science doesn't ask. They're not admissible questions. We don't know how to answer them in the context of modern science. Therefore, if a central part of Aristotelian natural philosophy, what are the final causes of things, are formally banished from modern science, well, no wonder that the appearance and the content of Aristotelian natural philosophy often appears quite different, often alien to us as compared to modern science. Well, having said that, I think what I'm going to do is pick up my crater and travel off to the oracle to pour a libation to the shade of Aristotle for so compressing his enormous and complex system into 60 minutes of lecture. When I return, we're going to visit the Lyceum and look at some of Aristotle's successors and the responses to his ideas.